Let's jump right into this.
Yeah.
Software quality. It's easy to think of it as just a technical thing, right? But the money involved, it's just, wow. Think about this. Poor software quality costs the U.S. economy something like $2.41 trillion a year.
2.4 trillion. That's a hard number to even wrap your head around.
It really is. And you can see why QA teams are under such, well, immense pressure these days.
And it's fascinating how the software world itself sort of created that pressure, isn't it? We're not just building simple apps anymore. It's all complex systems, microservices, cloud stuff, releasing code constantly with CI/CD. And users, they want perfection instantly, everywhere.
Yeah, expectations are sky high.
So quality assurance isn't just checking boxes. It's totally strategic now, absolutely critical for business survival.
Foundational, really. And for ages, the go-to solution, the reliable workhorse for handling all this speed and complexity was traditional test automation, TTA.
Exactly. That was the pillar. TTA is basically using tools, using code to run tests you've already defined. You set the script, it runs it, validates the software against your rules.
Keeps the manual work down during execution, at least.
Right. And it's different from, say, RPA, which automates tasks a user might do. TTA is purely focused on validation. Does this thing work like we expect it to?
Got it. Confirming it does its job. And the benefits, I mean, they were huge back then. Faster releases, getting products out quicker because you weren't stuck waiting for manual tests.
And way better accuracy, consistency. Machines don't have off days or make typos when they're running tests.
Yeah.
It's super efficient for those repetitive jobs, especially regression testing, making sure new stuff doesn't break the old stuff. That's crucial.
Yeah, keeping things stable as the app grows. And that efficiency, it scales up too. We've seen figures like teams boosting test coverage by 25% or more just by automating.
And the cost savings over time, reducing manual testing, significant ROI. Something like 70% of companies see that return within the first year.
That's pretty compelling. Hard to argue with those numbers.
It just became essential, a strategic must-have. You saw it in the tools. Everyone started using Selenium, Appium, Cypress, Playwright for wrestling with UIs,
Right.
Postman, SoapUI, JMeter for the APIs, Junit, TestNG down at the unit level. Those tools really defined that era of testing.
And you can picture it, right? Automating UI tests across all the different browsers, doing that manually, check-in, login, search, checkout on Chrome, Firefox, Safari, Edge, days of work.
Oh yeah, tedious.
But with something like Selenium, you can get it done in hours. Or think about testing complex calculations, like an e-commerce cart total with tons of item combos. Impossible manually at speed. TTA hits the API, validates it in less than a second.
It brought a whole new scale, a whole new speed. But, and here's the big but, as software kept getting faster and more complex, TTA started to, show its age. It has these built-in limits that are real pain points now.
Yeah, this is where it gets really interesting and, frankly, challenging for teams. The biggest headache seems to be how brittle these tests are. The maintenance.
Oh, absolutely. The maintenance overhead is notorious. Your app changes all the time, right? A developer tweaks the UI, renames something, refactors code.
And bam, your automation script breaks.
Exactly. The selectors are wrong, the IDs don't match anymore, and all that efficiency you gained running the tests, it just gets eaten up by the manual effort needed just to fix them, just to keep them running.
It's constant upkeep.
It is. Some reports say maintenance can consume like 50% of the QA budget. I've even seen figures suggesting 60 to 80% of a team's time is just spent fixing old tests, not writing new ones.
Wow, 60 to 80%. That's just running in place. It's a paradox, like you said.
It really is. And TTA just isn't very adaptable, is it? It's built on those fixed rules, those specific locators. If anything unexpected happens, anything it wasn't explicitly told about,
It struggles.
it struggles, especially with Agile and DevOps cycles where things change constantly. Updating scripts manually all the time is a huge drag.
And you still have human error, right? Not in the running of the test, but when people design or maintain the scripts, mistakes can happen there.
For sure. A badly designed script, a missed update. Plus, let's be real, setting up a solid TTA framework from scratch. That initial scripting takes a lot of time and skill.
Yeah, it's a big upfront investment. And maybe the biggest limitation. TTA isn't great for exploratory testing.
Exactly.
It validates what you already know should happen. It follows the script. It doesn't have that human knack for just poking around, trying weird things, finding those edge cases no one thought to write a test for.
That intuition piece is missing, which leads us nicely into the new player on the scene, generative AI.
The disruptor.
You could say that. Its fundamental difference from traditional automation, even traditional AI in testing, is that it can create. It makes new stuff, test cases, data, even code.
So it's not just following instructions.
No, it's learning from massive amounts of data and then adjusting what it does on the fly. It doesn't need someone to rewrite its code line by line when things change. That adaptability is key. Though the transparency is different too. GenAI can sometimes be a bit of a black box.
Okay, interesting. So it's more than just faster automation. It's bringing actual intelligence.
Precisely. It's changing the landscape, changing what's even possible.
All right, so how does that actually help? Where does GenAI tackle those TTA headaches we just talked about?
Well, take test case creation instead of a person manually writing out every single step.
Which takes ages.
Right. GenAI can look at requirements, user stories, even just plain English prompts, and generate test cases automatically. And it can often think of edge cases, complex scenarios that a human might miss.
Seriously?
Yeah, we're seeing potential to cut down the time spent just designing tests by up to 70%.
70%. Wow. Okay, that tackles the upfront scripting time. What about that maintenance nightmare?
This is probably the biggest win, honestly, self-healing tests.
Self-healing. How does that work?
So if a button's ID changes or it moves on the page slightly, a traditional script just breaks, right?
Right. Needs fixing.
A GenAI script can often figure out, okay, the ID changed, but based on the look, the text, the position relative to other things, this is probably still the submit button I'm supposed to click. It adapts the locator dynamically without needing a human to intervene.
Okay, that sounds huge.
It is. Reports are suggesting maintenance cost reductions of 40–70% and maintenance effort down by 70–85%.
That's potentially freeing up most of that 60–80% maintenance time we mentioned.
Exactly. Think what teams could do with that time back, and there's more. Intelligent error prediction.
Predicting bugs.
Kind of. By analyzing past test results, code changes, bug reports, user data, GenAI can predict where defects are most likely to pop up next, so teams can focus testing proactively on the riskiest areas, shifting left even further.
Proactive, not just reactive. Nice.
And then there's synthetic test data.
Generating fake data. Why is that important?
Because real data can be sensitive, privacy issues. Or maybe it's scarce, or it just doesn't have the specific weird combinations you need to test edge cases or performance or security.
Gotcha.
GenAI can create realistic, varied data that looks like the real thing but doesn't have the privacy risks. About 52% of QA teams are already using synthetic data now.
Okay, so give me an example. GenAI in action.
Instead of carefully scripting out, log in, search for blue widget, add to cart, verify total is $19.99, you might just give the GenAI a prompt like that user story.
In plain English.
Yeah. And it might generate not just that one test, but variations. Different login types, different search terms, adding multiple items, applying coupons, complex flows you didn't explicitly spell out.
Covering more ground automatically.
Exactly. Or the self-healing example.
Yeah.
The add to cart button ID changes. TTA script fails. GenAI script sees the button looks the same, is in the same spot, says add to cart, and just updates its internal understanding and clicks it. Test passes. No human needed.
That's impressive.
And it's being used in other areas too, like visual testing, comparing screenshots to catch tiny UI glitches TTA might miss, and fuzz testing, throwing unexpected malformed data at the app to find crashes or security holes.
It definitely sounds powerful. Addresses some huge TTA issues.
Yeah.
But
yeah,
there's always a but, right? What's the catch? The flip side.
There are definitely challenges. Cost is a big one. The potential ROI looks great, but getting started, that can be a heavy lift.
Also.
You need serious computing power, especially for training these big AI models, often specialized hardware like GPUs. Setting up GenAI for a large app could cost, $600K to $1.5 million just for infrastructure and initial setup.
Oh.
And then you've got ongoing costs, cloud usage fees, keeping the model trained and fine-tuned, integrating it all. It's not cheap.
So definitely not just plug and play. Major investment needed.
Exactly. And a really critical challenge is what they call the black box problem, interpretability.
Meaning you don't know why it did something.
Pretty much. The AI might generate a test case or flag an issue, but it can be really hard to understand its reasoning. Why this test case? Why does it think that's a bug? This makes debugging the AI itself, or even trusting its results, much harder than with traditional tests where you can see the exact steps and rules.
Yeah, that trust issue sounds significant. If you can't explain the why, how confident can you be?
Precisely. Which leads to another risk, getting too reliant on it.
Complacency.
Yeah. If testers just blindly trust the AI, they might stop using their own critical thinking, their intuition. The AI learns from past data, remember. It might miss completely new types of bugs, 0 days, weird issues, and new frameworks. Human insight is still vital.
So it's definitely not a replacement for human testers.
Absolutely not. It's augmentation. That human in the loop is critical. Then you have issues around the data itself.
Bias. If the training data is biased, the AI learns the bias.
Exactly. It can perpetuate or even amplify biases found in the data, which is a huge problem, especially for sensitive applications. Ensuring fairness means really careful data curation and validating what the AI puts out.
Garbage in, garbage out.
Oh.
Bias in, bias out.
Pretty much. And tied to data is security and privacy. Using sensitive production data for training. You need ironclad security to prevent breaches or even attacks that could poison the AI model, plus all the usual compliance headaches, GDPR, HEAA, etc.
Right, and just integrating this complex AI stuff into your existing tools and processes. That sounds complicated too.
It can be. It requires careful planning. And because GenAI learns and changes, you might hit unforeseen costs or need more resources down the line. Oh, and sometimes they just make stuff up.
Make stuff up. Hallucinations?
Yeah, they call them hallucinations. It might generate test cases that are totally irrelevant, nonsensical, or just redundant. You still need humans to filter that out.
Okay, so we have TTA, reliable, predictable, great for stable stuff, but a maintenance headache and not very adaptable.
A workhorse.
And then GenAI. Powerful, creative, adaptive, self-healing, but comes with costs, trust issues, black box problems, and needs careful handling.
The newcomer with huge potential and some growing pains.
If you put them side by side, their strengths and weaknesses seem almost like mirror images.
They really do, and that comparison makes it clear GenAI isn't just TTA on steroids. It's a fundamentally different way automation can work.
Like script creation. TTA is manual, slow. GenAI is auto-generated, potentially cutting that time by, 80%?
Huge difference. Maintenance. TTA is high cost, brittle. GenAI is minimal, self-healing, adaptability. TTA is rigid. GenAI learns, it's flexible.
Coverage. TTA covers what you tell it to. GenAI might find edge cases you didn't even think of by analyzing data patterns.
Speed. TTA executes fast, but the whole process, including fixes, is slow. GenAI promises faster overall cycles because it automates creation and fixes itself.
Bug detection. TTA does explicit checks, pass-fail. GenAI can do pattern spotting. This looks weird based on past data.
Right, anomaly detection. Cost ROI. TTA has known setup maintenance costs, proven long-term ROI. GenAI has higher initial costs, maybe, but potentially much faster, bigger ROI through those massive efficiency gains. We're seeing early stats like 41% ROI, 27% lower dev costs, 55% higher dev productivity.
Those are big numbers driving adoption, I bet. And finally, auditability. TTA is clear, deterministic. GenAI, that black box, makes audits harder, needs human oversight, lots of logging.
It really brings you back to that analogy, doesn't it? You don't use a sledgehammer for a picture hook.
Or a thimble to break concrete. Right tool for the job.
Exactly.
Which seems to be the main message coming through here. The future isn't TTA or GenAI. It's not one winner.
No, the smart money is on integration. A hybrid approach, strategic, synergistic.
Okay, so what does it actually look like? Hybrid.
It means using TTA for what it's good at.
Yeah.
The stable, predictable, repetitive stuff, your core regression suite. The bread and butter tests, logins, standard checkout flows, TTA handles those efficiently.
Okay, the basics.
Then you bring in GenAI for the heavy lifting where TTA struggles. Dynamic parts of the app, complex scenarios, generating test data, finding those weird edge cases, predicting potential problem areas.
So TTA for the knowns, GenAI for the unknowns, and the complex bits.
That's a good way to put it. And crucially, humans are still driving the bus. AI augments the humans, it doesn't replace them. Testers bring the intuition, the creativity, the ethical judgment, and they validate what the AI does. Human in the loop, always.
Right, got to keep people involved. And this hybrid way, it makes teams more adaptable, right? They can pick the best tool for whatever the project throws at them.
Exactly, you get the best of both worlds.
Are companies actually doing this now? Any examples?
Yeah, absolutely. Teams are definitely experimenting and implementing like a mobile banking app. They might use their trusty Appium and rest assured scripts for the core stuff login, transfers, rock solid TTA. But maybe for a new feature describing a user story, they feed that story to a GenAI model like GPT-4. The AI generates a bunch of complex test scenarios and data variations based on that natural language requirement.
And then what?
Then they might actually feed those AI-generated scenarios into their existing TTA framework for execution. So AI does the smart design, TTA does the reliable running.
Interesting. Using AI for the creative part, TTA for the execution.
Precisely. Or think of a finance company building a new AI-powered financial advisor tool.
Yeah, complex stuff.
Right. Their TTA handles the regular parts of their platform, but testing that new AI feature. With all the natural language input and complex data, they use GenAI heavily to design thousands of user queries, market scenarios, data points. Then maybe TTA executes checks against the API, and crucially, human testers review the AI-generated test and the financial advice results for accuracy and safety.
That makes total sense. Using each tech where it shines. Okay, so someone listening is thinking, right, hybrid sounds good. Where do they start? What's involved?
Well, first is organizational readiness. You got to look at your tech setup. Do you have the compute power, GPUs? How's your data situation? GenAI needs lots of clean, well-managed data.
Right, the data quality aspect.
And skills. Do your people understand AI? Maybe need some prompt engineering skills. And culturally, is the team ready to see AI as a helper, not a replacement?
So as people, process, and tech.
Definitely. Then tooling. You need the right mix. Keep your solid TTA tools for the core, maybe look at specialized AI testing platforms. Functionize, Test Sigma, tools like that for the advanced stuff.
Makes sense. Mix and match.
And integration into CI/CD is key for both. Tests need to run automatically, provide fast feedback. AI can actually help here too, with the auto-generation and self-healing, keeping pipelines more stable.
Okay, tight integration. And what about managing those AI risks we talked about? Governance.
Super important. You need frameworks for this. How will you mitigate bias? Maybe diverse training data, lots of human review. How will you handle the black box? Maybe using explainable AI techniques, or just really rigorous validation of outputs. And obviously, solid security and privacy controls around any data used. It sounds like you really need a strategy, not just buying a new tool. Absolutely. It's a journey, requires learning and adapting as you go.
So, wrapping this up, we started with that massive pressure on QA, that huge $2.4 trillion cost of poor quality. We saw how TTA stepped up, gave us reliability for repetitive tasks, but kind of hit a wall with maintenance and change.
The reliable but brittle workhorse.
Then GenAI arrives, this transformative force, creating, adapting, predicting, tackling TTA's weaknesses, but bringing its own set of challenges: cost, trust, the black box.
Yeah, the powerful but sometimes mysterious newcomer.
And the clear path forward, the consensus really, isn't choosing one over the other. It's not a fight.
No, it's about intelligent integration, a hybrid future, AI amplifying what humans can do.
Humans bringing the strategy, the critical thinking, the intuition, AI bringing the speed, the scale, the pattern matching power. Together, they tackle that $2.4 trillion problem more effectively.
That's the vision, a much more resilient and efficient approach to quality.
So the final thought for everyone listening: given this shift, this blend of traditional reliability and AI intelligence, how might you or how might your team need to adapt? Your skills, your processes, maybe even just how you think about solving quality problems. What's maybe one small area where you could try integrating just a little bit of AI, see what happens, and start learning?